Hi. So for question 3a, we've been told that the waiting time at a doctor's surgery is assumed to be normally distributed with standard deviation of 3.8 minutes. Given that the probability of waiting more than 15 minutes is 0.0446, find the mean waiting time. Okay, so for this question, we've been asked to find the mean waiting time. Okay, we've been asked to find mu. Okay, mu is the letter we usually assign to mean in statistics. Okay, so the first thing I'm going to do is I'm going to define my random variable, Q layer 1. So I'm just going to write a little statement here, and I'm going to say let x be the RV waiting time. Okay, RV stands for random variable. Okay, so I've stated that x is the random variable. And I'd recommend you to do this also for hypothesis tests and questions as well. It's very important to state what your random variable is. Okay, so now I can say that x is normally distributed with a mean of mu and a standard deviation of 3.8 minutes. Okay, so the variance is therefore 3.8 squared. Okay, so you should be familiar with this notation. Okay, so the next thing I'd recommend you to do is to draw a nice big diagram, Q layer 2. Okay, so here I've got two normal distribution curves directly above one another. The first one is going to be the normal distribution curve that shows how waiting time has been distributed. Okay, so I've denoted it with the letter capital X. The second one is going to be our standardized normal distribution curve, and it's usually used with capital Z. Okay. So now I can start to plug in each of these values. Okay, so I know on my normal distribution curve, I can put the mu here because we know the mean is in the middle. And now I can start to fill in the probabilities. Okay, so we've been told that given the probability of waiting more than 15 minutes is 0.446, okay, we can therefore say that the probability that x is greater than 15, because now we know what x is, we've told the marker that x is our random variable waiting time, so the probability that the waiting time is more than 15 minutes is equal to 0.0446. Okay, so if I was to put that in to my normal distribution curve, where would x be? Where would our observed value be? Well, we know that all the probabilities under the curve sum to 1. Okay, so therefore all the probabilities that's greater than our mean is 0.5. Okay, we have 0.5 on the left side of the mean and then 0.5 on the right side of the mean. Okay, so we therefore know that our observed value must be on the right side of the mean. Okay, it must be here, because once I shade it in, it will be a little bit more evident. So I know that 15 lies here, and I know that this probability is 0.0446. Okay, 0.0446 is less than 0.5. So in order to be above this observed value of 15, it must be on the right hand side of mu. If 0.0446, if this probability was instead, for example, 0.51, it was more than 0.5, we would know that 15 would lie here. Okay, because we know all of this probability, all of this part of the graph is 0.5. Okay. Okay, so we can now transfer this down onto our standardized normal distribution curve. Okay, so we can say there is an observed value z, which corresponds, and we usually give it small z, which corresponds to our 15 minutes, and the probabilities are exactly the same. Okay, you should be familiar with this. So we therefore know that this probability is also equal to 0.0446. Okay. So now, in order to find the mean, what we need to do is find what this observed value is. Okay, what is the observed value on the standardized normal distribution curve, which has the probability of being greater than it equal to 0.0446? Okay, so for this we can use our tables, but there's one more thing that we need to do before we use our tables, because we know that our tables always give us probabilities less than certain observed values. Okay, so what we need to do is find the probability that we are less than z. Okay, so we can say the probability that z is less than our observed value, small z, is equal to, well, all the probabilities add up to 1, so therefore it's 1 minus 0.0446. Okay, and if you plop that into your calculator, you should get 0.9554. Okay, so now we can simply go to our tables and find this probability of 0.9554. Okay, as a small rule of thumb, a lot of students ask me, when should I use the small table and when should I use the big table? Okay, so if you've been given a probability and you're trying to find an observed value, my rule of thumb is to always check the small table first. Okay. If you've been given an observed value and you're looking for a probability, you're going to be using the big table. Okay, whereas if you've been given a probability and you're looking for an observed value, check the small table first to see if it's there, and if it's not, check the big table. Okay, so Q layer 3. Okay, so I've got a little schematic of what the table should look like because I can't fit the whole table here, unfortunately. So you should see that the probability 0.9554 corresponds to a value of 1.70. Okay, so we can therefore say Z is 1.70. Okay, and it's positive, which is good. Okay, because we know that the mean of our standardized normal distribution curve is 0. Okay, so our value is positive, it's good. If we got a negative value, we would know that something is going wrong. Okay, so now you should be familiar with this formula. This is the transformation formula, okay? And it simply states that an observed value on the standardized normal distribution curves can be obtained by simply taking the observed value on the normal distribution curve for the question, minusing the mean and dividing it by the standard deviation. Okay, that's how we transform observed values from one curve to the other. Okay, so what I'm going to do now is I'm going to write out this formula again. I can say z equals x minus mu over standard deviation and simply substitute all of these values in. Okay, so I know my observed value z is 1.7, 0. I know the observed value x is 15. I don't know what mu is, and I know the standard deviation is 3.8. Okay. So if you simply rearrange from mu, just bring my calculations off to the side here so they don't go off to the bottom of the page. Timesing both sides, multiplying both sides by 3.8, you should get 6.46 is equal to 15 minus mu. Now rearranging for mu, so what I'm going to do is I'm going to add mu to both sides and minus 6.46 from both sides. You should get a value mu equals 8.54. Okay, very important to remember the units as well. The units for this question is minutes. Okay, so I hope this helped. Thank you very much.